Welcome, everyone. You've made it to the last presentation of the day. Congratulations. We hope that you've learned a lot, listened to thought-provoking discussions, and have been inspired to continue asking questions and encouraged to respectfully push each other in the name of pipeline safety. During this panel, we will hear about geohazards, how they affect pipeline integrity, what is being done to address this ongoing concern. If you haven't seen us already on another panel, my name is Amanda McKay. I'm the policy manager with the Pipeline Safety Trust, and I have the pleasure of co-moderating this panel with my boss down there at the end, Erin Sutherland, Policy and Program Director / Counsel with the Trust. We have a very full panel here today with some of the leading voices in this space. Panelists, if you could please take just a very brief moment to introduce yourselves, including your name, position, and who you are representing today. A very quick introduction, and then we'll be able to get more into the nitty-gritty later on. So we'll start here and move on down.
Iain, sorry, am I on here? No.
I think closer.
Tough being dumb and having an accent. Sorry about that. No, I'm on. Iain Colquhoun is my name. I'm the professional leader engineering at the Canada Energy Regulator. Canada Energy Regulator is sort of a combination of PHMSA and FERC. It was formerly known as the National Energy Board of Canada. And my job is to develop technical expertise within the CER and provide technical guidance where I can. I'd like to say real fast is I first became involved with geohazards in 1979. The Simonette River crossing failed in 1978, and the company that I was working for then was known as Alberta Gas Trunk Line. It is now TCE. Needed someone to look at the failure. So I really appreciate being here today, especially to hear the feedback from the communities that could be affected by pipelines. This will help us in our outreach activities.
I'm Nick Homan. I'm the Integrity and Corrosion Engineering Manager for Marathon Pipeline. We're responsible for the integrity management program execution at Marathon, and that includes our geohazard program.
I'm Kurt Baraniecki, Director of Pipeline Integrity for Enbridge Gas Transmission and Midstream. I've been in the integrity group within Enbridge, both liquids and gas, for over half my career, which is more than 15 years doing that, 25 years with Enbridge. Really passionate about geohazards. That's what my undergrad engineering degree is in. And happy to be here and have an opportunity to share what we've learned from our recent incident and how we can work together to improve safety in the area of geohazard management.
Yeah, hello, Chris Ruhl. I'm the director for PHMSA's accident investigation team. We're out of the field operations group of the Office of Pipeline Safety. We've got predominantly accident investigators spread out across the country to investigate accident investigations, as well as a data analyst to try to understand those lessons learned and emerging issues that then we can share with industry and the public.
I'm Rick Kuprewicz, president of Accufacts. We tend to have slightly over 50 years experience investigating some of the most major failures in North America in the last 50 years, more so than the last 25 years. We tend to represent the public and local governments and state governments, helping them understand which questions they ask and whether or not the questions are being answered truthfully and completely.
Great. Thank you for those introductions. So I just want to run through a brief introduction to the subject, just so that we can all start on the same page as we listen to this discussion. And these are the experts up here, so I'm sure that you'll hear a lot more about these aspects as we move through. So Geohazards is a very broad term used to describe hazards such as earthquakes, landslides, sinkholes, washouts, floods, and more that pose risks to the integrity of pipelines and other infrastructure. These hazards can be caused by weather or climatic conditions such as heavy rain, soil saturation, gradual land movement, among others. In Sutherland, Mississippi in 2020, we saw the impacts of geohazards on a CO2 pipeline where a steep embankment experiencing subsidence and heavy rainfall caused a landslide. And this land movement caused an axial strain on a girth weld, and the pipeline eventually ruptured. The photos after the incident, including this one on the screen, are incredibly telling as to how land movement affected the line. And the stories from the affected community and the heroic first responders in Sutarsha really do prove why this issue is so important. In the Appalachia region, we're seeing similar issues of incredibly steep and rocky terrain, a long history of landslides and risks from earthquakes, and the increased impacts of climate change. There are many people here today who experience these impacts every single day. These threats are in their communities, next to their schools and hospitals and homes. So I just want to take a moment to thank all of the people here that are here sharing their stories and their concerns and asking questions related to this region specifically. And lastly, I just want to ensure that we're all aware of 2 advisory bulletins that have been put out by PHMSA on this subject specifically, one in 2017 and one more recently in 2022, that specifically advise, and advise is the key word here, that operators consider monitoring geological and environmental conditions, including changing weather patterns in proximity to their facilities. So I'm sure we'll hear more about these advisory bulletins, but it's definitely a question that we're asking, is whether or not these advisory bulletins are making a difference, and what more we can do in relationship to geohazard risks. So I'm going to pass it off. We have just a couple of very brief presentations, and then we're going to jump into the discussion. So it looks like, Nick, you're up first. And it's just this button forward and this button.
Thanks, Amanda. Yeah, you can see up on the screen, we're going to cover an incident that we had at Marathon Pipeline in March of 2022. And what we're going to talk about is the incident briefly, and then what we've done to our geohazard program to improve it, to enhance it, to proactively identify geohazards before they cause a pipeline issue, and really focused around utilizing technology and integrating that technology to identify geohazards. So just first up, just for the folks that aren't familiar with Marathon Pipeline, a brief slide on, we're primarily a hazardous liquids pipeline operator, crude oil, gasoline, diesel fuel, jet fuel, and some NGL, natural gas liquids. We operate 26 states and have roughly 10,000 miles of pipeline. So that's our business. And then getting into the incident that occurred, first thing I'd like to say is this incident's still currently under NTSB investigation, so the final causation has not been determined. But we did get permission from the NTSB and PHMSA to do operator info share 25 days after the incident, and we wanted to do that to quickly, share what we could about the incident and what we thought were some key factors that created the incident. And we were fortunate enough that API supported the event, and we had over 900 participants, a lot of our peer operators, And what we did was this was a slide from that info share about the incident. You can see in the really in the middle of the slide, you can see that the pipeline is running basically up and down the middle of the slide. It's a 22-inch crude oil pipeline, and then there's this creek called the Cahokia Creek near it. The pipeline was about 40 feet away from the edge of the stream. And this area of the country, this is in Edwardsville, Illinois, which is on the western side of Illinois, right outside of St. Louis, Missouri, on the other side of the Mississippi. So it's not mountainous terrain. It's more river bottom, low kind of flat land into the Mississippi. And you know, what we do know that happened on the top side of that slide, there's a bridge for State Route 143. And you can kind of see how the stream comes underneath that bridge and kind of is directed towards the bank near the pipeline, and repeated low-level flooding events over probably a 10-year period slowly scoured away the bank and gradually pulled the pipeline towards the stream, putting strain on the pipeline, and it failed at a girth weld that you see in the slide. And it's really and Amanda mentioned it, it's a slow-moving landslide type geohazard. And we wanted to let other operators know about it because a lot of our focus had been on pipelines that cross streams and scouring and vortex-induced vibration type failures. And this one was a little different, that it pulled it into the stream and caused the failure. And then this is a slide of the site. We just wanted to show that, you know, we worked very hard on the site to restore it and put in remediation to prevent future problems with that scouring of the bank and that slow-moving landslide. What that is we put in a sheet pile wall, you know, about 30 feet down, anchored it into the bedrock at the site, and put a concrete cap on it. And then you can see the riprap in front of it, and then there's we put strain gauges on the pipeline using technology that we can monitor in our operations center. And if we notice any, you know, strain movement past our limits, you know, we can immediately respond and prevent another incident in this location. And then what I'd like to move into now is, you know, after we had this incident, you know, as part of the pipeline safety management system process, the plan, do, check, adjust cycle, we said, hey, we've got to figure out how to identify these geohazards proactively, and we need to lean into technology to do that. And, you know, as everybody knows in the room here, you know, technology advances very quickly nowadays. And if you look at your phone and the ability for GPS on your phone and to know where you're at and, you know, where things are geospatially has really advanced. And so what we did was we were already using, you know, various inline inspection tools. And you can see on the slide, in the middle of that slide, there's a picture of an inline inspection tool. And they have inertial measurement technology on them that can give you that GPS positioning. And we really ramped that up. We were already using them, but we wanted to run all of our lines that were susceptible to geohazards. So we did that through the remainder of 2022 and into 2023. And you can use the information from that technology to identify bending strain on the pipeline and the pipeline if it's moved from one run to the next. And that can tell you if you have a geohazard impacting your pipeline. And then another technology that we really ramped up usage of after the event was LiDAR. And that's when and this technology, it was mentioned before in an earlier panel, but uses laser-based technology on on a plane, and you can map your right-of-way, and it can measure, it can give you a 3D digital surface model, and it can also identify ground movement. It can penetrate through vegetation. And the nice part about it is it can tell you might have a landslide that hasn't started to impact your pipeline, but it's starting to encroach on your pipeline. So integrating this information with what the IMU tells you, you can say, hey, we have an issue here and we need to get out there and put a remediation in place to prevent another pipeline failure. And then finally, I just wanted to summarize in the end here, you know, we went ahead and just revamped our geohazard program, you know, after this event and said, hey, we're going to rank all of our pipeline miles for susceptibility to geohazards. If they're in the upper two categories, we're going to immediately get out there and do inspections with geotechnical experts and confirm, you know, if we think from the bending strain, IMU data, LiDAR data that we might have a geohazard, we're going to take action and we're going to mitigate that geohazard and we're going to remediate that site. And we've had numerous projects since this event to prevent further pipeline issues from geohazards. And we also are heavily involved in the development of the API recommended practice pipeline integrity management for landslide hazards, which is 1187. And that's where the industry's coming together. You know, we'll share our knowledge. I know Kurt's going to come up here and share what Enbridge has done with their program. They share their knowledge. We try to put it all together in an industry document so we can help other operators to prevent further issues. And the same with the PRCI, PHMSA-based research programs that were mentioned earlier in a panel. You know, we participate in those because the real issue here is try to, you know, weather-related patterns change, and how do we manage identification of these hazards, because they are somewhat random. And there's other technology that we can probably talk about under one of the questions later on if we have time. Thank you.
Thank you. Thank you, Nick. It was a great presentation. Marathon and Enbridge for several years have been working together on joint projects to try to improve standards as we move forward, and Geohazards has been one we've been working on for several years. Just a little bit about Enbridge. So we're North America's leading energy infrastructure company. We ship over 30% of the crude oil produced in North America through pipelines, over 20% of the natural gas consumed in the U.S. through our gas transmission pipelines. We're the largest gas distribution utility in North America by volume. And in the early 2000s, we started investing in renewable energy, where we now have over 45 renewable power facilities across several countries, including the U.S., Canada, England, Germany, and France. I'm here to talk about our Hillsborough, Kentucky pipeline incident that resulted in a rupture and a fire in our pipeline. Certainly an incident that we've learned a lot from. We worked really closely with PHMSA following this. They did take significant enforcement action on us following this incident, which resulted in a pressure restriction on our entire pipeline corridor that had 3 large gas transmission pipelines in it that spanned from Mississippi all the way to Pennsylvania. So we worked on developing a remedial work plan to address any potential geohazard in that corridor to make sure it was safe before we went back to full operation. It was a great effort and a great collaboration to try to mutually advance the understanding and improvement of geohazards in industry. So just a little bit about this picture. So the top right is really before the incident happened. You'll note there was some grading that was done there. There's some erosion control there. And you'll see that that green line in the middle has a little bit of a curvature. So we had a geohazard program in place prior to this incident. We had really started to kick it off in 2018, 2019 to advance it using inline inspection technologies and field assessments. This picture was taken during a field assessment the fall of 2019. The incident itself occurred in May of 2020. In the fall, what our engineers had seen when they went on site was, yes, it's being impacted by a landslide because you can see the pipe is moving. They looked at how and what rate of movement that would cause that level of curvature. And we had estimated that we have until the summer to design and plan a mitigation. So we were planning kind of in the summer time frame, about 1 month after the incident occurred, to actually be out on that site to repair that pipeline. The NTSB did investigate. They've concluded that investigation. I'll talk a little bit about it. But what we learned in that was we were not conservative enough in how much movement a pipeline can take before it could potentially fail, especially a pipeline that's been in the ground for several years, in this case, over 60 years. The incident occurred, you can see the picture on the left, that is shortly after it happened. You can see there's a lot of water in the trench. Water is probably the biggest challenge with landslides. That's what causes it to move. So moving the water off the site is a good way to help control or slow the movement, but that certainly is illustrative of what was causing it. When our engineers were on site to do that assessment, you can see that it was graded. That actually had covered up some of the signals that would tell them the land is moving quicker than it should. So that was certainly one of our learnings as well, that you have to build into other geohazard programs. On the bottom of the left, that's the after. So that slope is large. It is moving, and we realized we would have to do a major reroute or a major HGD, but there's several slopes in that area. So this is Kentucky, the Appalachian area. So we developed a permanent solution, which is a bridge that essentially bridges most of the land movement, and if there is movement, it will actually go underneath that bridge. So we've decoupled those pipelines in that area from any of that potential movement as a pretty stringent mitigation measure. So what the NTSB did find is that the probable cause was that our analysis of the landslide did not fully address uncertainties associated with the pipeline defects, the landslide movement, and any of the corresponding pipeline response. They did acknowledge that the work we did to improve our procedures, working with PHMSA to develop that remedial work plan, we went to over 400 sites with PHMSA inspectors on that right-of-way to assess and make sure we were addressing them properly. And they did note that PHMSA's work of enforcing it and providing the advisory activity was there. So out of the response, they didn't come up with any safety recommendations, but acknowledged everything that we had done in working correct with PHMSA. So what we had done is very similar to Nick's program. So it involves gathering way more data on your pipeline, whether it's technology through IMU, through LiDAR, change detection, applying that technology. And on the right-hand side, it's developing a decision model that allows you to classify every geohazard on your pipeline and to know when to act. That allows the regulators and our own internal auditing group to audit whether we're actually doing what we say we're going to do. So there's thresholds. We really reduced our thresholds of when to act, so they're much more conservative. And then we have a response matrix that says when and what you have to do and what frequency you have to continually monitor. As we were doing this, and in discussions with PHMSA and other operators in INGA, part of the INGA IMCI 2.0 initiative, we established a joint industry project to develop a recommended practice with API that can be ideally adopted by regulators as code of what all operators need to do to manage the landslide threat. Our hope is this is phase one. We'll get into hydrotechnical hazards and other type of geohazards, but this was one where we've seen recent incidents. We as an industry, led by INGA and working with API, and PRCI is going to do a lot of research that has come out of this, felt this is what we need to do to help raise the bar on geohazard managements for landslide movement in industry. And here's the companies that we worked with. That recommended practice today is at its first ballot, expected to be released sometime Q2 2025 once we address the comments. And that will be something that all industry can point to that'll say, here's what you need to do to manage that landslide threat. Nick and his team have been working closely with our team, and those are the other companies we've worked with, plus all the API companies.
All right, thank you for your presentations. Somebody left their phone up here. All right, thank you for those presentations. So I'm going to be moderating this discussion. My first question is, PHMSA's efforts to address geohazards has largely been via these advisory bulletins. PHMSA's advisory bulletins, and maybe Canada's efforts, seem to lump together geohazards that have very different causes and consequences and mitigation methods. Iain, to set up our discussion, can you talk a little bit about what CER has been doing to encourage operators to mitigate against geohazards? Are there any specific geohazard regulations in Canada?
Sure. CER has what it calls OPR. It has the onshore regulations, and it's in those that the geohazards are addressed. What I will say about them, in the existing form, they're very generic. So they say that a company must identify a hazard, must have measures in place, must have measures in place to control the hazard. What we're doing now is we're trying to introduce to it specific requirements for geohazards, because we've known about this being a problem for a number of years. It's an increasing problem. In the early years, the fact that we saw fewer was probably because of reporting, and now we're being much more insistent on reporting. The other thing that we're putting into the regulation that's a little weak right now is the interaction of threats. The particular interaction, and we've seen mention of it here today, the particular interaction that affects geohazards is the geohazard on the girth weld, the weld that joins the pipes together. If there's defects or deficiencies in the girth weld, then the geohazard will cause a failure at that point. So in particular, and we've put out a safety advisory on this, is the undermatching of girth welds, where the girth weld does not have the same strength as the pipe beside it. And then the last thing that we are in the middle of trying to formulate is how to essentially do the same thing as PHMSA has done, is to have companies account for climate change in the integrity management program. We recently, 2019, we recently had a failure, a series of failures in British Columbia, 46 in the end, by the time they were finished, 46 cases where pipes had become exposed. And what we discovered in our investigation is that the company had used a 200-year return period for the flood, and that they had actually ended up with a larger flood than the 200 years. So we would like companies to take that into account when they're putting their integrity management programs together.
Thank you very much. Rick, can you take a couple minutes and speak about the technical differences between different geohazards and their mitigation methods?
Sure. I've had a chance to review the latest industry studies, 2017, and I forget the other one, the INGA study. And a lot of efforts got into those, but they're missing a couple of major points that are very important. Probably the greatest threat to many pipelines in elevated terrains that are shifting is what we call, and I know we're not supposed to use technical jargon, but guess what? Breakaway landslide. Write that one down, okay? It just means what it says. You're minding your own business, and then instantly, essentially, for various reasons, and there are three factors that come together normally, water being one of them, terrain, elevation, steepness is another, and the soil condition. And if those all come together in the wrong combination, for whatever reason, you get a breakaway landslide, basically fairly instantaneous forces, tons of force on a pipeline that usually results in a rupture, usually at the girth weld, but more importantly, the heat affected zone. Okay? And this isn't any secret. The last thing I want to hear is that you're just following API 1104 regarding girth weld practices, all right? more prudent operators nowadays, again, this isn't, it's not here to scare anybody. There's lots of girth welds that meetings 1104 won't have terrain threats on them. So it's a different animal. They'll operate just fine without that. But if you're a candidate for breakaway landslide and you haven't gotten appropriate heat treating after your girth weld, you're a candidate for a rupture if you get massive breakaway landslide. And I only say this not to cause anxiety. There are some pipelines, I think you heard some people talking this morning about the Mountain Valley pipeline. Okay, you ought to be nervous. Congress cannot repeal the law of gravity. They may think they can, I don't believe they do, but again, more prudent operators will be ahead of that curve and try to avoid those threat factors coming together that place that, because nobody wants a pipeline rupture, especially a 42-inch gas transmission pipeline that you're going to see from space. The other category of landslide threats that are not as dramatic as the breakaway landslide are what we call the slower time frame, what we usually call in the industry land creep. The forces are placed on the pipeline, but in a longer period of time. And so there you can use various technologies like inline inspection to monitor your stress forces. For breakaway landslides, inline inspection technology is going to tell you nothing except maybe the angle. And so you just got to be cautious about that. Don't set yourself up believing your integrity management program is complete if you've got the three factors that can create a breakaway landslide. And again, many pipelines in Canada and the United States do not have those three factors, but others do. And so I guess the last geohazard threat that can be fairly rapid but puts different forces on a pipeline would be things like the sinkholes or the mines that break, that drop the land. They put forces on the pipeline, but they're different forces than the breakaway landslides in steep terrains where water's been introduced and the soil conditions liquefy the soil and gravity kicks in. Again, many operators are way ahead of this, so this isn't, I'm not trying to scare people. I don't need to investigate any more ruptures. I get enough calls as it is. Anyway, that's my spiel.
Thank you, Rick. My next question, I think we'll start with Chris. Is the blanket approach that PHMSA is taking effective or rational given the differences between different geohazards and interactive threats? And does it ensure that operators are considering all geohazards and protecting against them or on their and protecting against them on their systems?
Yeah, thanks. So first of all, I think it's probably important for everybody to recognize that PHMSA's expectation is that pipelines are operated safely and that threats are identified prior to going to failure. And so, specifically talking about geohazards, our expectation is that they know what geohazard threats are, or even if geo threats apply to that pipeline, and then they're taking those steps. I wanted to mention that one of the big things that we noticed between the advisory bulletin that was issued in 19 and then the one that was issued in 2022 was the geohazard incidences we had post-19 had a component of heavy historic rainfall. And so that is where we wanted to make sure that if pipeline operators weren't keenly aware and they weren't taking heed, again, I talked about our team, PHMSA, is trying to distribute lessons learned so that so pipelines can be safer. And so if you weren't paying attention, that may be a nuance that you might just say, well, hey, geohazards haven't been a risk. We've evaluated that risk. It's not a threat, and so therefore I'm not looking at it. And so the reason for the 22 advisory bulletin is just to make sure that all operators are keenly aware of that. So that's what the expectation is, and I think that another lesson learned. We talked about advances in technology. the use of the IMU, ILL tools, so you can establish baselines and then understand a movement from when that initial IMU was done. I think that's another important step that we've made in terms of just understanding movement on pipelines in general.
I'm going to ask one more question, and I'm hoping to get an answer from all the panelists on this one. So it might be our last question before we do audience Q&A. So climate change has been and will continue to increase the frequency, severity, and intensity of geohazard threats to pipelines. Marginalized communities all too often face more frequent and severe effects of climate change. How will regulators and industry work to protect these already overburdened communities? Do regulators and operators use tools such as EPA's EJ screen to identify EJ communities while working to prioritize protection measures or repairs?
Yes.
Sorry. This has to be taken quite seriously. I mean, I give you a quantitative number, the 200-year flood being exceeded. It now requires the companies to put more effort into modeling what that change is going to be like. You can't rely entirely on history, but the communities can help if they are aware of conditions that should be brought to the company's attention, where there could be a sensitive response to changes in climate. Someone, I forget who it was, a little earlier today said that the landowners or the land users know the land well. And I think it's very important to leverage off that knowledge, and especially with respect to the effect that climate has on the land. Yes,
At Marathon, we started using this new data set, the EPA screen, and there's a few other data sets we use to look at really on the consequence side of our risk management equation. You know, we're driving for zero incidents on the likelihood side. So even with that in mind, even if we think we've driven that to zero, this is another data set we can look at on the consequence side and say, hey, you know, due to the uncertainty of weather patterns, maybe we should take some further action due to the location of the pipeline and its impact on the communities that it goes through.
At Enbridge, we do use the EJ screening, but we just consider that a start. So we add the layers within that, within our e-mapping system, so our internal mapping system, so every employee, every project knows the communities and where they're operating in. This allows us and our teams to really assess what's needed in terms of engagement, any additional work with the communities that we're involved with, and to establish detailed engagement plans for that. We fully support API RP 1185 on engagement. We're part of the leadership that did that, and we have strategies and tactics to identify, to collaborate, to engage, and to support the disadvantaged communities, the EJ groups, both in terms of considerable on-the-ground engagement through community support, and finally, we have a systematic means of assessing the integrity of all of our pipelines across the system. We don't treat them differently anywhere, but we do know that we need to do a better job in terms of engagement following API 1185 in those areas.
Yes. I'm not familiar with the EJ tool, EPA's EJ tool, but PHMSA recently published or posted, I should say, socio-equity maps online. One of the things that we do is working with our state partners, as well as when we conduct our own inspections, is we want to make sure there's the same level of safety, regardless of where it is on the line. And so, so in terms of disadvantaged communities, making sure that they have the same level, they're afforded the same level of safety as anywhere else on the line. And so that's something that is shared with our inspectors, but also with our state partners and their inspectors to make sure that that's being accomplished.
Yeah, I would just add, in the PHMSA order to Denbury following the rupture, that was a breakaway landslide, obviously. And forget the climate change, folks. If you know anything about that western Mississippi area, you get a lot of water. And if it's in steep terrain and you haven't been watering your right-of-way, you're in trouble. Anyway, PHMSA's order was look down your pipeline and identify other areas of risk. And guess what? They found a whole bunch of them, okay? So that's a good thing. So PHMSA knows this stuff. And breakaway is only one of the threats, but it tends to result in a girth weld type heat-affected zone rupture. So PHMSA could decide, if it doesn't get control of this situation, is to start issuing a more prescriptive pipeline safety regulation saying you will monitor your right-of-way for a certain steepness of terrain, the type of soil that be conducive to liquefaction from water if water is diverted to the site, to the right-of-way. So PHMSA knows this stuff. I'm not speaking for them, but I have a high degree of confidence. They know their technical stuff regarding these issues, and they're getting tired probably of getting embarrassed by having a rupture occur when it was very avoidable. All right? That's all I have.
Thank you. So we're going to move to questions from the audience. If you've got a question, raise your hand high. We also occasionally get questions from online.
Yeah, I've got one online I'll
Okay.
kick it off with, and then I'll walk over to somebody.
Okay.
So this question came in online. How is Marathon evaluating misaligned girth welds in geohazard areas? That would be an area most likely to fail.
So, one thing we do is we try to determine the tensile strain capacity of our girth welds on our systems, and that's part of building out our geohazard program. And so if we would think we would have misalignment with the weld and that impacts its tensile strain capacity, we would go out and do some remediation to improve that capacity. And one of the things you can do is expose the girth weld and oversleeve it with a steel sleeve. So that is a variable that you want to take into account based on how your pipelines were constructed.
So my name's Jennifer McKay, and I'm from Michigan, and I served on the Michigan statewide Pipeline Advisory Board. Part of what the state asked of Enbridge with respect to Line 5 was for a water crossings study, which they provided. And as part of that, they identified areas where there's deterioration in the pipe cover and sites where the pipeline was exposed due to geohazards. Enbridge actually applied for permits to do remediation on those sites, and then the state of Michigan actually determined that the remediation measures would cause adverse impacts to the sensitive water resources. So to date, no action has been taken on a number of these sites, and work has not been complete. So it's a three-part question. How do we balance the impact of remedial actions and the harm it can cause on the resources with the need to protect against those geohazards? And I'll give the example, I'm not trying to pick on Marathon, but the steel or the sheet piling and the riprap is obviously quite harmful for the ecological health of the river system. And then is there a way to conduct these type of fixes in a more environmentally friendly manner so we can both protect the environment by doing the fixes and protect against the geohazard? And then what do we do in the state of Michigan where we have all these known sites where it's been scoured and exposed pipelines and the state is not allowing them to be fixed?
I'll address the first part, the first question about the sheet piling and the riprap. And yeah, that is a challenge, and we always try to work with the regulators to protect the environment as much as possible while also trying to prevent the threats to the pipeline. But that's something we can, continue to work on with, new technology and new remediation methods to try to do as minimal impact to the environment as possible where we're at.
As we look at our geohazard program and identify those sites that need remediation, we bring a multidisciplinary group together, including our environmental team, our landowner, our land and right-of-way team, as well as our technical engineers to find the best solution for each unique situation. And we do it in a manner that is going to provide the long-term protection for public safety, for the environment, and be the least invasive. We're looking at new technologies where we can. We look at different types of composite pipe materials, such as smart pipe. Can we install that in certain areas instead of having to just remediate and place an existing steel pipeline or continue to do that? So we're often looking and investing in research and development and new technologies, working with our various stakeholders to find the best solutions to be proactive in managing safety and the least impactful way to the environment.
I wonder if I could add just one thing to that. Environmentally friendly repairs. There are other considerations too, and one that the CER has had to mediate recently, and that is cultural. If there's a cultural significance of a particular piece of land, you may have to take further the normal precautions in crossing that land. So not just environmentally friendly, but culturally sensitive also.
I would just add that adults in a room had to be able to come to a common agreement if there's a real legitimate threat to a pipeline, especially a transmission pipeline. It isn't always easy for the adults to be in the room and take the lead when everybody's yelling at each other. But these are fairly simple technical issues that can be overcome. And in some cases, if you have to leave a pipeline uncovered, that depends on the location and the type of threat, that may not be a problem. But this isn't rocket science. It's fairly straightforward engineering.
My question is for Mr. Baraniecki from Enbridge. So in 2010, Enbridge personnel testified in Congress that response to a spill could be nearly instantaneous. 10 days later, Enbridge let Line 6B spill for 17 hours into the Kalamazoo River, an important Great Lakes tributary, spilling 1.1 million gallons of tar sands. In the Line 3 construction in Minnesota more recently, there were 28 frac outs, each one a separate Clean Water Act 404 violation. There were 4 aquifer breaches. The drilling tech failed 63% of the time during construction. On Line 5 in Michigan, where I come from, 20 years past, Line 5 is operating 20 years past its planned lifespan. It's spilled 33 times already. It was found in violation of its easement with the state from 1968 until 2020, when the state of Michigan revoked the easement. The Bad River Band in Wisconsin evicted Enbridge 10 years ago, and Enbridge continues to trespass on tribal property by running Line 5 through it to this day. Despite the easement revocation and shutdown order from the state of Michigan, the eviction from Bad River, Enbridge continues to operate Line 5 in what experts call the worst place in the Great Lakes for an oil spill. So my question is, why should communities like ours continue to trust Enbridge not only to operate this pipeline, but also to build an unprecedented oil tunnel underneath the Great Lakes, despite this pattern and history of violations of permits and, frankly, not taking safety taking safety seriously enough?
I think I'll just remind the group that I'm with our gas transmission business unit, so I don't speak for liquids, but I am an Enbridge employee. And we work certainly in the state of Michigan. We have worked really closely with the state. We have worked with the regulators, federal agencies as well, to come to a solution that's good for Michigan. So we're continuing to operate Line 5. We're working to replace it through the tunnel, and we're continuing to work through that permitting process. Again, we are very focused on maintaining and protecting safety of persons and the environment, and delivering the energy to people to support their quality of life. And we're going to continue to do that.
Hello, my name is Nancy Andrews. I'm an independent journalist out of Pittsburgh. This question's for Richard about the breakaway landslides. You mentioned some of that with, I'm curious to know, like, is there a threshold of steepness that you would look at before building there, or what do you do if you've already does the rock content have an effect on that too?
The answer is yes. But the devil's in the details. What's the specific location? What's the soil type? And more importantly, or just as important, what's the propensity for water to enter into that area and cause liquefaction where gravity kicks in, takes over and just causes a landslide that moves with tons of force. And you out of Pittsburgh had a recent phenomena that took out a big old power line, a bunch of other stuff on a fairly new gas transmission pipeline that, again, you know, cooler heads would have said, we've got a risk factor here, what are we doing about it, rather than have a line rupture less than a couple of weeks after it went into service.
Yeah, I think they were just in testing phase, that one. If you're talking about
well, maybe a different line.
Yeah.
Okay.
But I mean, would you say 30% grade, 70% grade, or, I mean, is
There is a grade factor, and it may be a scale related to the type of soil, but then you throw water in on top of that. So I would say, I'm not going to give you an answer because in today's, every once in a while it's a yes or no. It depends. And I'm not trying to be cute, I'm trying to be honest. But yeah, there is going to be some steepness of grade. I'm seeing some pipelines go into areas that we would never put a pipeline in given that grade. Now, these are different times. And the time value of money and the multi-tons of costs or multi-billions of dollars of pipeline costs can drive people to shorter distances and put them into terrains that they wouldn't normally take. And that's not all companies. Many are standard. So I think there is a parameter there. You know, if you keep on having to issue advisory bulletins for this, my recommendation as a PHMSA, you need to prescribe certain standards that may be a sliding scale. That says if, you know, basically, you know, PHMSA doesn't want to get into siting issues, but if you're into areas that can become threats to transmission pipeline ruptures, you know, this is the threshold. Now, you need to explain why you want to exceed that, would be an example.
but figuring out the threshold?
Yeah, and it's fairly steep.
Can I just add a little to that? So within our Geohazard program, as well as a best practice that's going into the recommended practice or the proposed recommended practice with API, involves identifying and classifying each potential geohazard on your pipeline, which includes the grade, the length, the slope, the material, trying to look at historic slip planes where water could impact it. And you would have to assess, does it have that propensity for a sudden landslide failure, some large translational? We've had cases within our company where we made the decision to shut down a pipeline and relocate it because we knew there was that possibility that there could be one of those slides. That's what we would expect operators to do, is to assess each one and make a determination of what is the threat to the pipeline, when it can impact the pipeline, and what do we need to do to mitigate that. And that can involve everything from pressure restrictions, repairs, stress release, and in some cases, relocate to get it right away from that geohazard.
And your LiDAR technology has been a wonderful tool. It's been around for quite a while now, but people are using it and they're saying, hey, this helps us understand our right-of-way better. That's a positive technology.
Is anybody sort of studying, you talked about this being newer, because these are I mean, now we have like 42-inch pipelines going on these steep grades. And so there wasn't this historic information about that.
No, this is breakaway landslides, been well known by people who are experienced in the industry. I'm old. Okay, so I guess that's a...
You're not old.
Oh, yes, I am. You're a nice young one. I'm an old guy. But we were talking about breakaway landslides on the Trans-Alaska Pipeline when it was a dream in the late 60s. All right? And there is an area there that's public. It's in a concrete box because of its steepness and other factors. But it's worked just fine for many decades. So, that's an extreme, all right? But there are technologies like LiDAR that can help a pipeline to tell us, well, we didn't know we had steep terrain. No, you're an operator, you're saying that? That's not credible. It puts PHMSA in a situation, they don't want to be out there hitting you with a big stick. They want people to have a safe operation.
Thank you.
Let's see, we have time for probably one more question.
I told Irene I would get back to her,
All
so
right.
keep my word here.
Thank you. I'm Irene Leach from Southwestern Virginia, and when the Mountain Valley Pipeline was going through the approval process, one of the concerns that my community had was that there's lots of karst in our area. That's not a soil type, I don't think you'd say, but it's, anyway, we raised the money to get an expert to put something together for us, and we didn't see anything changed from the DEIS to the FEIS. And we've also had the company to say when I wish my friend Carolyn Givens was here, and she could tell you about the cave on her property that got caved in through this process, and the company swears there was never a cave there. But and we know we have sinkholes every so often. How do landowners get what we know paid attention to in these processes?
Well, yeah, I think, and Kurt mentioned it before, but at Marathon, we would want you to pass that type of information back through our company representatives that you're working with for the right-of-way acquisition, and then we would take that into serious consideration. And because the karst limestone structure, it is challenging to work with, and it's good for us to know that. Other things would be like if you knew there was an old mine on your site. We a lot of the states have maps of old mines, but that helps us think about mine subsidence and where should we go with the pipeline and how we route it and those type of things. So we would find that to be valuable information.
I'd just also add, in the terms of the karst where you get the sinkholes, and all, that's again you've removed the soil from underneath the pipeline, but the engineering approach to what a particular pipeline, grade, thickness, whatever, can span if a hole were to open up is very calculable. A good engineer will be honest with you and straightforward and say, this is what our loading calculations are, and we're well away from an abnormal loading threat, or we're in an abnormal threat. They had to be able to defend that. They had to have those records as part of their pipeline operation. And if they're being straightforward and honest with you, which isn't always the case, they ought to be able to demonstrate that the pipeline can handle within a reason. Now, sinkholes can be fairly large, and a 42 inch isn't your normal span type. That adds all kinds of force. But the current regulations requires the pipeline operator to have those abnormal loading threat calculations in their files, and a prudent operator will have that with appropriate conservatism.
All right, thank you, everyone. I very much appreciate our panelists for joining us today, and thank you, audience members, for your excellent questions. Bill has a couple announcements to make, but maybe a round of applause while he comes up here.